Okay. So when we say thermal stress, stress din siya, kaya lang nai-induce siya dahil sa changing temperature, okay? So almost ang lahat ng bagay, especially the metal ones, pag nag-change ng temperature, let's say uminit, okay, nagkakaroon siya ng expansion. Okay? Kaya kung mapapansin nyo, pag sa mga railway ng MRT, no? So medyo pansin nyo ng konti. So yung MRT, yung mga dugtungan nun, hindi yun magkakadikit. So there is a certain part na meron siyang gap. So the purpose of that gap is para kapag uminit, okay, temperature, yung dalawa, mag-expand siya, okay, and then magta-touch pa lang siya dun sa dalawa, okay. So kasi kapag fix na fix siya, tapos uminit siya, wala nang pagmumuvan yung mga material mo. So ang tendency, ma-overstress siya, no? So iniiwasan natin, ma-overstress yung mga materials natin kasi madali siyang masira. Okay? So, yung strain na tinatawag, okay? So, remember we have the strain before, so that is the deformation all over the total original length, okay? So, you have here the strain, okay? Kapag temperature ang pinag-uusapan, if we are speaking for the temperature, meron tayong tinatawag na alpha and then delta T. Okay? So, this alpha is called the coefficient of thermal expansion. Okay? So, kada material, iba-iba na ang coefficient of thermal expansion. So, iba yung sa steel, iba yung sa bronze, iba yung sa aluminum. Depende sa gagamitin natin. Okay? And then this delta T, ito yung ating change in temperature. Okay? It's either by degree Fahrenheit, degree Kelvin, degree Celsius, or Rankine. Okay? Now, if we are going to solve for the deformation, since ito, okay, kung strain yan, we will be having here deformation over the L, and that is alpha delta T. So to solve for the deformation due to the temperature, we will be having here alpha L delta T. So this is actually the formula that we are going to use when it comes to the deformation caused by the change in temperature. Okay? So kadalasan lahat ng bagay, pag uminit, nag-expand, no? Except, excuse me, except sa case ng mga timber or mga kahoy. Yung mga kahoy, baliktad siya, no? Kapag umiinit, nag-shrink siya. Kapag lumalamig, nag-expand siya. Kaya pansinin nyo minsan, pag malakas ang ulan, tapos malamig yung panahon, yung mga pinto, ang hirap isara, no? So, nag-expand kasi siya. So, yung tubig around dun sa kanyang atmosphere, ina-absorb niya yun. So, it causes it to expand. Ngayon, kapag mainit, yung mga moisture lumalabas dun sa mga fibers ng timber or ng mga kahoy, resulting it to shrink. Okay? But most of the time, when we will be having here increase in temperature, nag-expand siya, and then we will denote that as a positive, okay? We will denote that as positive elongation. And then kapag nag-shrink naman siya, we will denote that as a negative elongation, okay? Or shrinkage. Now, to give an idea, okay, on how to solve for problems including the change in temperature, I have here an example. Again, I have posted it. Excuse me. This problem is from Pytel, example 2.11. Okay, so papaliwanag natin. So the horizontal steel rod, 2.5 meter long and 1,200 millimeter square in cross-sectional area, is secured between two walls as shown. Okay? If the rod is stress-free at 20 degrees. Okay? So ibig sabihin, at 20 degrees Celsius, saktong-sakto na yung length ng bakal mo is 2.5 meters. Walang sobra, walang kulang. Okay? It means, kung saktong-sakto siya at this distance na 2.5, wala pang stress na nai-induce sa kanya. Okay? So, we will be having here initial, okay? So we will be having here initial temperature as T1. So that would become equal to 20 degrees Celsius, okay? Compute the stress when the temperature has dropped to negative 20. Ulitin ko, has dropped to, okay? Dalawa yung terms madalas. Iba yung has dropped to and drop by. Okay? So, pag sinabing drop to, bumaba sa. Okay? So, in short, ang aking final temperature or T2, that would be negative 20 degree Celsius. Okay? Pag sinabing drop by, bumaba ng, di ba? So, ibig sabihin, iyon na yung delta T kapag drop by. Okay? So, kapag drop to, ibig sabihin, yung delta T natin, okay, that would become equal to final temperature or T2 minus T1. So we will be having here as negative 20 minus 20. So ang ating delta T is negative 40 degrees Celsius. Okay? So ito yung ibinaba ng temperature natin. Okay. Unang question, sabi niya, the walls do not move. Okay? So eksaktong-eksakto siya. Okay. Now, ang gagawin ko, okay, ay, hindi ko pala dapat dyan din drawing, no? Sige, lipat ko dito. Yung ating solution. So, T1 is equals to 20 degrees Celsius. And then T2, negative 30 degrees Celsius. So, our delta T is equals to T2 minus T1. Okay? So, we will be having here negative 20 minus 20. So, our delta T is negative 40 degrees Celsius. Okay? So, i-drawing ko muna. Okay. Tatanggalin ko, okay, ang gagawin kong technique, okay, assuming tatanggalin natin yung support. Okay, tatanggalin natin yung support na to. Okay, tsaka natin papalamigin. Okay? So, ang tendency, para kang nakahawak dito, and then, yung ating pinaka-rad, assuming, okay, dahil lumamig, ang mangyayari, nag-shrink siya. Okay? So, ito yung aking deformation due to temperature. Okay? Madaling makuha si deformation due to temperature. Okay? Kaya lang ang tinatanong, compute the stress. Sir, paano mako-compute yung stress? Okay? Kasi, supposedly, kung wala kang support, mag-move siya ng gantong kalaki. Okay? Kaya lang, dahil meron kang support, originally, meron naman talaga doon, hypothetically, so dapat hindi siya mag-move. Okay? So, yung second free body diagram natin, what we will do is, we will try to pull it, okay, by a certain force P. Okay? Hanggang sa mag-move siya on this part. Okay? So, again, ito nag-move on this direction. Okay? Ito mag-move on this direction. Pero ito, we will cause it by a certain force P. Okay? So, we will be having here a certain force P. Deformation. Okay? Now, if we will see, it should be that the deformation due to the thermal stress or to the temperature should be equal to the deformation due to the force P. Okay? So, in short, my deformation due to temperature should be equal to my deformation due to the force P. Now, this is alpha L delta T, and this is PL all over AE. Okay? Again, this term is actually sigma or our stress. So, we will be having here alpha L delta T is equals to sigma L all over E. Okay? Next. So, we will be having here Okay? So, as you can see, we have 2.5. We could cancel it, the L. So, yung alpha L natin, that would become, ang stress natin, eto, we are solving for the stress. So, that would become equal to alpha E delta of T. Okay? So, we could have it this way. So, ang alpha natin is 11.7 times 10 to the negative 6 per degrees Celsius. Okay? And then, multiply natin by E. Okay? So, yung E natin is in gigapascal. So, could have it as 200. Gawin natin MPA, 200,000 MPA. Okay? And then, multiply natin by 40 degrees. Okay? I-disregard ko na, no? I-disregard ko na yung negative sign kasi alam naman natin siya ay shrinkage. Okay. So, check. So, that is 11.7 times 10 to the negative 6 times 200,000 multiplied by 40. Okay. So, you will be having here 93.6 megapascal. Okay. So, this is now the stress induced, okay, by the temperature by dropping it from 20 degrees Celsius to negative 20 degrees Celsius. Question? Question? Okay, sige. Kopya muna. No problem. Walang tanong? By the way, no? Next week would be your quiz. And topic is all about the statically indeterminate and thermal stress. Okay, so it will run for 2 hours. So in short, co-cover natin yung full 3 hours nyo, no? Yung first 2 hours would be your exam. And then the last hour would be the topic. Okay, in torsion. So you will be having here next kasi February na. So magpa-finals na kayo. Torsion pa lang tayo. Okay, so we need to finish, no? Shinrink kasi yung shinrink yung academic year nyo. Meron naman daw kayong IL, independent learning. So expected nila na inaaral nyo on your own. But I doubt on that. No? Mahirap aralin ng mag-isa. Okay? Question? Okay, so let's continue the problem number 2. So yung una, naka-fix siya. Second, yung walls daw mag-move together by around 0.5 millimeters. Okay? So in short, okay, ito yung original. I-drawing ko muna yung original natin. Okay? So, dahil sa temperature, sabi ko nga, pumunta siya dito. Okay? Pero, ang mangyayari, okay, para ma-move natin siya, i-move natin, okay, lagyan ko dito. Ayan. ito, mag-move by a certain temperature. And then ito, hihilahin kasi natin yung P, ano? Hihilahin natin yan by a certain force P. So, this one would be the elongation due to the force P. Pero dahil yung support natin magmo-move together, isa lang naman yung tinanggal ko, no? So, isang support na lang yung i-move ko para ito yung nagmo-move dito. So, magmo-move to, yung part na to, by around 0.5 millimeters. So, iyon yung ating delta. Okay? So, mathematically, if you are going to write it, so yung ating delta T should become equal to our delta P plus our the elongation. Okay? So, yung movement ng ating support. Now, delete ko na to. All right. So, going back, so we can have it as alpha L delta T should become equal to PL all over AE. Plus, the delta, no? Yung 0.00, yung 0.5 millimeters. Okay. Since we are looking for the stress, okay, so we can have it alpha L delta T is equals to sigma L all over E plus delta. Okay, so we will be having here, ilipat natin sa kabila, alpha L delta T minus delta is equals to sigma L all over E. Solving for this one, so we can have it as E quantity alpha L delta T minus delta all over N. Or we can have it as E alpha delta T minus delta all over L. Multiplied it by E, of course. Okay? So we will be having here this one. Now, substitute. Stress is equals to E as 200. Sige, ito na lang gamitin ko para hindi nakaano. So, 200,000 para in megapascal. And then alpha L, alpha, 11.7 times 10 to the negative 6. And then multiplied by delta T. So that is equal to 40 degrees Celsius. And then minus, we can have it as delta 0.5 mm all over 2,500. Ano? Okay, so we will be having here 2,500. Okay? So ito yung original length, no? Yung 2,500. So we can have it as stress equal to 200 times 10 to the 3, 11.7 times 10 to the negative 6, times 40 minus 0.5 all over 2,500. Okay. So you will be having here 53.6 megapascal. Okay. So as we can see, syempre, mas lumiit yung stress. Definitely, no? Kasi yung movement ng temperature natin is shrinkage. So, patulak na pa ganun. Tapos, yung support natin, patulak din. So, in short, yung movement ng support gumalaw na naaayon doon sa temperature. Pero, kapag yung movement mo, okay, for example, yung temperature mo is mag-move towards shrinkage, pero yung yielding ng inyong support is papalayo, you expect na lalaki yung inyong stress. Ano? Okay? So, that is for this kind of problem. Question po. Madali lang naman, di ba? Sige. Kopya po. Okay. So let's have this problem. Figure A shows, so ito yung figure A on the left side, shows a homogeneous rigid block weighing 12 kips that is supported by 3 symmetrically placed rods. The lower ends of the rod were at the same level before the block was attached. Determine the stress in each rod after the block is attached, and the temperature of the bars increases by 100 degrees Fahrenheit. Use the following data given the area, the E, and then the coefficient of thermal expansion in per degrees Fahrenheit. Okay. So, ang mangyayari, we have two different materials. No? So, we have the steel and then you have there the bronze. So, ang condition niya, bago daw ilagay yung 12 kips na block, the same level yung bottom ng lahat ng bars. So, ibig sabihin, level sila. No? What would you expect kapag nilagay yung 12 kips? Because very symmetrical yung bronze and steel, definitely bababa siya at the same amount, no? Pero kapag magkaiba yung material mo, hindi symmetrical, let's say ito naging bronze, ito steel, they are not symmetrical, you expect na hindi rin magiging level yung pagbaba ng block mo. Okay? Pero in our case, dahil very symmetrical silang dalawa, pag bumaba yan, equal sila. Unahin muna natin, ano? Pagbaba due to the weight. Okay? Assuming, exaggeratedly, ito na yung magiging block ko pag dahil sa 12 kips. Okay? So, you will be having here the delta S. You will be having here the delta B. And then you will be having here the delta S also. Okay? Also, okay? Kapag increase, so ibig sabihin, mag-expand siya, no? Kapag yung bar mo ay nag-increase by 100 degrees Fahrenheit, it will further lowers the end. Okay? So, bababa pa yun ang gusto. Okay? Assuming, eto na yung final position. Okay? Yung final level natin. Okay? So, nandito na yung ating 12 kips. Yung deformation na to, cause na siya due to temperature. Okay? So, tawagin natin TS. And then, tawagin natin tong TB. And then, tatawagin ko rin tong TS. So, okay? Now, itong dalawa, nasa gilid, they are perfectly the same. Okay? Equally the same. Kasi, same material, tapos, same pa siya ng length. Okay? With this deformation, ang pwede kong makonclude is that pag pinagsama ko pala yung deformation ng bronze, so deformation ng bronze due to the 12 kips, plus deformation ng bronze due to the temperature, ito, mula dito at this point hanggang doon, equal din siya sa deformation ng steel, plus the deformation ng steel due to temperature. This would be our working equation. Now, yung deformation ng bronze is due to the force na na-receive ng bronze. So, tatawagin natin ng bronze. Tatawagin ko siyang PB, no? So, P, L all over AE of the bronze. And this one is alpha L delta T of bronze. And this one is also PL all over AE of steel plus alpha L delta T of steel. Okay, so you have there the working equation. Ngayon, sige, total kompleto naman tayo. So, isa-isahin natin. Gagawin natin yung feet, gawin natin inches kasi masyadong yung given is naka-PSI and inches squared. So, i-multiply lang natin by 12. So, para sa bronze, we will be having here PB. Okay? Ang L ng bronze originally is 3 feet. So that is 3 multiplied it by 12. Okay? And then all over, ang A ng bronze is 1.5. At ang E ng bronze is 12 times 10 to the 6. Okay? Plus, yung alpha ng bronze is 10 times 10 to the negative 6. Ang L is 3 times 12. Ang delta T natin is increased by around 100 degrees Fahrenheit. Okay? And it should become equal to those of the steel. So we can have it as P sub S. Okay, this time that is just 2 multiplied it by 12. All over, we can have it as 0.75 of E. So ang E natin is 29 times 10 to the 6. Plus, so we will be having here alpha, 6.5 times 10 to the negative 6. Ang L natin is 2 times 12. Ang delta T natin is 100. So this is the working equation. Okay, so ilipat ko lahat. So dito, isimplify ko to. So 3 times 12. So 3 times 12 all over 1.5 times 12 times 10 to the 6. So, ayan. 2 times 10 to the negative 6 of PB minus itong term na to, this term. Okay, iyan ko rin. 2 times 12. Oops. All over 0.75 times 29 times 10 to the 6. Okay, so that is around 1.103 times 10 to the negative 6. And that is the PS. Okay, so ito, plus, i-minus ko to kasi sa kabila. So that is 6.5 times 10 to the negative 6 times 2 times 12, multiplied it by 100, minus 10 times 10 to the negative 6 times 3 times 12, multiplied it by 100. Okay? So that is negative 0.0204. Okay? Meron kang isang equation. So you have here equation 1. Now, what you can do is that pagdating dito, ang pwede natin gawin is by submission forces vertical. Okay? So meron akong 12 kips. Okay? So yung 12 kips na to, pagtutulong-tulungan siya ng tatlong material. Okay? So again, meron ka ditong P sub S, meron ka ditong P sub B, and then meron ka ditong P sub S. And then meron kang 12 kips. So if I'm going to have it submission forces vertical equal to 0, I could say, okay, that 2PS plus PB is equal to around 12 kips. Okay? So gawin na natin 12,000 kasi naka-pounds naman siya. Okay? So with this would be your equation 2. You got equation 1 and then you got equation 2. So let's solve simultaneously. 2 times 10 to the negative 6, negative 1.103 times 10 to the negative 6, negative 0.0204, then 2, 1, 12,000. All right. So you will be having here, wait lang. You will be having PS is equal to negative 1,703.28. Okay. And then this is around 15,000 for the PB. Okay. Check muna natin. P bronze is 15,406.56 pounds. Okay? I-double check muna natin. Baka may ano ko. So, PB, 3 times 12, PL all over 8. E is, okay, that's correct. Plus 10 times 10 to the negative 6, L, delta T. So 100 degrees, PS. Okay, good. So 3 times 12 all over 1.5 times 12 times 10 to the negative to the 6. So that is 2. Then 2 times 12 all over 0.75 times 29 times 10 to the 6. Okay, so that is around 1.103. Okay. Next, P alpha L delta T. Okay, and then this one, 6.5 times 10 to the negative 6 multiplied by 2 times 12 times 100 minus 10 times the negative 6 12 times 100. Okay, so negative 0.204. 2 times 10 to the negative 6. 0.103 times 10 to the negative 6. Negative 0.0204. Okay. Sorry. It should be, ginawa kasi natin tong, but that's correct, pounds. PSI. Negative 1703. Ang sagot ko kanina ay nasa 8,500. Okay. So, saan tayo nagkamali? Solution. Still. Okay. 6.5, 2 times 10. And then 10 times 10 to the negative 600, 312, PBR 1.5. Okay, that's correct. What's wrong? Wait, bakit may kaiba ng sagot? 6.5 times 10 to the negative 6, 100, 2 times 12 plus PS 2 times 12.75 times 29 times 10 to the 6. Okay, then 10 times 10 to the 6. Okay. Arranging it. PB. Nakikita nyo ba kung saan ako nagkamali? Kasi mag-iba ng sagot. Okay. Okay. Try akong iba. So we can have it as PB is equals to 12,000 minus 2PS. 2x times 3 times 12 all over 1.5 10 to the 6 plus 10 times the negative 6 3 times 12 times 100 is equals to x 0.75 times 29 times 10 to the 6 to 100. Okay. Solving for PS. Ayun. Tama. So, PS is 7,000. Magkaiba. Lumalabas. Why? Have you seen it? PB minus, kung makita yung mali 29 times 10 to the 6. So, 1 point times 10 to the negative 6 PS. Oops. And 3 times 12 times 100. That's correct. Why? 2PS 2 times negative 6. Ayun, 8,700. Okay. Hindi, mali lang pala ako ng ano. Mali ako ng pindot. Okay? So, ayun. Sa pwede to, substitute natin on this part. Okay? So, we can have it as 2 times 10 to the negative 6. Ang PB natin is 12,000 minus 2 PS. Okay? Then, minus 1.103 times 10 to the negative 6 of PS equals to negative 0.0204. Okay? So, solving simultaneously yan. So, we can have it as ayan ka na. PS is equals to 8,700.76 and your PB would become 12,000. Okay, solve natin siya. 12,000 minus 2 of PS. So, you will be having here negative 5,401.53. Okay? So, you are in pounds. Okay. Now, since you have that yung pinaka-negative dun sa bronze, it means it is a compressive force. Okay? So, ang nangyari, yung pinaka ano natin, so ito yung 12 kips. Okay? Yung dalawa, pahila. Okay? So, you will be having a compressive stress on the direction, no? So, yung isa is tension and then yung isa is in compression. Okay? So, iyon yung tulong natin, yung dalawa, no? Kumbaga, ang nangyari, instead, yung pinaka-bronze natin, compression siya, and then yung dalawa is in tension. Okay? So, ganun lang yung naging ano niya. So, in short, pag nakuha natin yung stress niya, para sa steel, so you can have it as PS all over area ng steel. So, ang steel natin is 8,706.76. I-divide ko yun by the area of the steel, which is 0.75. So, you have the stress. 8,706.76 all over 0.75. Okay, so that's 11,609.01. So, this is unit is in PSI. Okay, so same thing. So, this is in tension. So, yung compression natin, so that is for the bronze. So, that is equal to negative 5,401.53 all over the area ng bronze. So, that is around 1.5. So, stress natin, 5,401.53 divided by 1.5. Okay, so that is around 3,601.02 PSI, and that is in compression. Okay, question. Ang tagal pa ako dun sa sa pagkakalagyo. Okay. Calculate the increase in stress in each segment of the compound bar if temperature is increased by. Okay? So, the word is by. So, in short, yung ating delta T is automatically 80 degrees Fahrenheit. And it is an increase. Okay? So, assume that the supports are unyielding. Ibig sabihin, hindi nagmo-move and the following with the following data. Okay. Ay, nasa na yung mga data. Okay. Ito pala yung data. Okay. Okay. Now, ang mangyayari niyan, okay, so katulad ng ginawa natin kanina, tatanggalin natin yung isang support. Okay. So, we will remove the support. And what might happen is medyo at this point, humaba siya ng kaunti. And then humaba rin yun ng, i-suggest ko na, haba rin yun ng kaunti. No? So, from here, up to this point, so yun yung aking total deformation. Okay? But technically, that deformation is due to the deformation of the temperature of aluminum plus the deformation due to temperature of the steel. Okay? Kailangan maibalik ko siya sa original. So, I have to push it backward. Okay? Pag pinush ko siya backward, so technically, magkakaroon siya supposedly ng deformation. Okay? So, the deformation, kasi dalawa yung material niya, ito magmo-move din doon. Okay? So, that would also be because the movement of the steel and the aluminum and then the steel. Okay? So, working equation natin, deformation of the aluminum due to temperature plus deformation of the steel due to temperature is equal to the deformation of the aluminum due to the force P plus deformation of the steel due to the force P. Okay? So, ganun lang kadali. And then, meron naman tayong alpha for the aluminum. So, we can have it as 12.8 times 10 to the negative 6. Ang L natin for the aluminum is 10. L delta T is 80. Okay, alpha L delta T plus for the steel 6.5 times 10 to the negative 6. Ang L ng steel is 15. Ang T is 80. Okay? Now, kung meron akong P dito na magtutulak, if I'm going to cut the section on this part, okay, yan. Kung meron ako ditong P, so definitely dito ang P. So that is your P sub S. Ngayon, para makuha natin si P sub, yung parang ginawa natin dati, para makuha natin si aluminum, okay, so also you will have it as P sub A. So in short, from this diagram, yung PS natin is equals to P, and then yung PA natin is also equal to P. Okay? So P na lang gagamitin ko. So P, ang L ng aluminum, over ang A ng aluminum, ang E ng aluminum, okay? Plus, for the steel, ang L ng steel, 15, ang A ng steel, 2, ang E ng steel is 29 times 10 to the 6. Okay? With this, I can now have the value of P. So, 12.8 times 10 to the negative 6 multiplied by 10 times 80 plus 6.5 times 10 to the negative 6 multiplied by 15 times 80 equal to 10p all over 1.5 times 10 raised to 6 plus 15 of p, 2 times 29 times 10 to the 6. And you will be having here the value of p equals 19,496.65 pounds. Okay? So, if you're going to have it for the stress ng steel, so that is 19,496.65 all over the area of the steel, which is 2. So divide by 2. So you will have it still 9,748.32, and that is in PSI. Okay. So for the aluminum, so that is 19,496.65. Okay, divide natin by the aluminum of 1.5. So the aluminum is 12,997.76, and that is in PSI. Okay. So that is the answer for this problem.